3.4 kilogram bomb traveling at 68 meters per second along the increasing x-axis explodes into exactly two pieces. One piece of mass, 1.5 kilogram, travels parallel to the y-axis at 1.3 times 10 squared meters per second immediately after the explosion. What is the velocity of the second piece immediately after the explosion? What is the impulse generated by the explosion of the whole bomb? What is the impulse generated by the explosion on the 1.5 kilogram mass? So, first thing we're supposed to do is to draw a little diagram to understand the problem. So we have a bomb. So here's our x-axis, here's our y-axis, and we have a bomb traveling. It explodes into two pieces. One piece goes in the y direction. So we'll call this. Another piece goes down in the bottom direction. So an explosion, a large mass bomb explodes into two pieces, going up and going down. We'll call this M1. So M1 happens to be 1.5 kilograms. There's a mass, let's call it M, before the explosion. There's a mass of 3.4 kilograms. So M2 is going to be the total mass minus M1. Only two pieces. So the mass happens to be 1.5. 3.4 minus 1.5 gives me 1.9 kilograms. So we have mass M2. We're told that V1 happens to be V1 of the mass going up happens to have a speed of 1.3 meters per second up, and so V2, second piece V2, that's what we're trying to find. The initial velocity is given by the speed is 68 meters per second, so 68 meters per second. So we're going to say the total momentum before is equal to total momentum after. The total momentum before happens to be mv as a vector, and that's equal to m1 v1 plus m2, the second mass, times velocity v2. And this is what we're trying to find, v2. So I'll move this term to this side and divide by m2, so v2 vector is equal to mv vector minus m1 v1 vector divisible by m2. The mass happens to be 3.4. The velocity of the original particle is 68 I hat. So remember, directional vectors, I hat is up, I hat is this way, and j hat is up in the y direction. So 68 minus m2, mass of, m1 happens to have a mass of 1.5, and it's going up, so it has a velocity of 1.3 times 10 to the squared j hat. It's going up, all divisible by the total mass of m2 happens to be 1.9 kilograms. So we can plug this in. Let's get out the calculator. Where's the calculator? Okay. So 3.4 multiplied by 68 divisible by 1.9. So this would be 1.2 times 10 squared I hat then we have a j hat, which is 1.5 multiplied by 1.3 exponent squared divided by 1.9. I get minus 1.0 times 10 to squared j hat. And the standard units are kilogram meters in seconds, so the velocity is meters per second. So it's traveling at 120 meters per second in the x direction and down by 100 meters per second down in the j direction. We're also asked, what is the impulse generated by the explosion of the whole bomb? Okay, so total momentum is always conserved, and so we expect that approximately that. So we know that gravity is pulling down on it, but if the interaction time is very, very small, we expect that the total momentum before is equal to total momentum right after the explosion. They're equal to each other. So the impulse for part B, which is what is the impulse generated by the explosion of the whole bomb? The total impulse is 0, because that's equal to the total momentum after minus the total momentum before. That's equal to 0. Part C, and we'll have to calculate this. What is the impulse generated by the explosion of the 1.5 kilogram mass? So part C is the impulse on mass 1 is equal to sigma momentum on mass 1 after minus the total momentum on mass before. That's the total impulse acting on the object. And that's equal to m1 times v. Let's call this 1 final, 1f, minus v1 initial. So the mass happens to have, it's 3.4. Actually, the mass of m1 happens to be 1.5 kilograms. The final velocity happens to be 1.3 times 10 to the 2 j hat. The initial velocity is part of the mass, so it's clumped together, traveling 68 meters per second, so it's going to be minus 68 I hat meters per second. So bring out our calculator and calculate the impulse to be 68 multiplied by 1.5 is 1.0 times 10 squared I hat minus plus j hat is 1.5 multiplied by 1.3 exponent squared, which is 2.0 times 10 squared j hat. And this is the impulse for the second part. And the standard units of impulse is going to be in units of momentum, which is going to be in kilograms per meter per second. So we have an impulse, an applied impulse on the mass number 1 to be 1 times 10 squared kilogram meters per second in the x direction, so it's acting this way, and 2 times 10 squared j hat in the up direction, kilograms meters per second.